Okay, so we're going to look at an exponential model. You've seen it in these two forms before. We're going to be concentrating on this one. We know that b has to be greater than 0 and b cannot equal 1. And we know a is the initial amount. And then we know a little bit about if b is greater than 1, we know it's a growth model. It's increasing, and it goes like that. If b is between 0 and 1, it's a decay model. It's decreasing, and it goes like, well, like that. Okay, so that's just a brief review of exponential models. So it says, in 2007, a university study was published investigating the crash risk of alcohol-impaired driving. Data from 2,871 crashes were used to measure the association of a person's blood alcohol level, BAC, with the risk of being in an accident. Now that's a lot of data. You're looking at almost 3,000 crashes. You're getting almost 3,000 ordered pairs to graph. Okay, but that's what we want to do to get accurate models. Okay, so the results are in the table. Now they didn't give us all 3,000. They just gave us, some of them were probably repeated, but they just give us the data that we have. I think there are 12 points that they give us. The relative risk is a measure of how many times more likely is a person to crash. So, for example, a person with a BAC of 0.09 is 3.54 times as likely to crash as a person that's not been drinking alcohol. So they're talking about this data point right there. Okay, so what we're going to do is we're going to try to graph this and see what model it fits. To do that, we need to get a grid. And I often draw these by hand. It's helpful if we have a ruler. Okay, so that should be enough for us. And then we have 12 ordered pairs. We already counted that up. And then it's our output, the highest output. You can look at all the outputs, but they're increasing. It's going up to like 100. So let's count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so I needed it a little bit bigger. And this is the risk. Risk. This is the BAC down here. Now we want to put in some units so we know when we're graphing it how to measure that. And then we're going to count by, it's really hard to fit this in, 0.04. We're going to say, and then 0.08. We're going to count by 0.04, I guess. 0.12, 0.16, 0.20, and then this last one would be 0.24. Okay, now that's how I'm going to go ahead and label them. I'm skipping every other line just because it gets all crammed in there and you can't read it otherwise. Okay, so now I'm going to have a little trouble with the scrolling here, but let's see. 0, 1, so that's where it's starting. Like way down here. Okay, a little bit above the x-axis. What was the next point? 0.1, 1.03. So 0.1, let's see, that's going to be like right in there. And then the next one was 0.03, 1.06, so not very much bigger. So, oops. 0.3 is just a little, it's just still really not growing much. Okay, we can look at that as I scroll back and forth. Sorry about this. So 0.05, still just, it's not even to 2 yet. So 0.05 would be like right in there. We're almost done with that first line. Then 07 is 209. So 07, still, we're not even a third of the way to 10. All right. And now we are 09, 3.5. So 09 is going to be you know, like maybe there. All right, now I'm to this point where it's 0.11 and it's jumping up to 6. Okay, so we're over halfway to our first tally mark now. And we have this one, and that's going to be above. So it's going to be maybe there. And then this point, 0.15, is 22. So now we see some growth happening. Oh, it should be over a little bit this way. 0.17, it's going to be right there, and we're going up to 39, so almost to the 40. 0.19, and that's up to 65.3, so let's see, 0.19 up to 65, so up there, and 0.21, which is going to be right here, up to 99, like way up there. So look at those ordered pairs. You can see they're just really flat for a while, but then they really start to take off, right? So it's showing that that increase is really, or the risk is really increasing as the alcohol increases. Okay, so that's our graph. It definitely looks like an exponential model, exponential growth model. And then if you have a graphing calculator, you can go through, it's in the textbook, I'm not going to show it here, but you can go through and actually find those, the values for A and B. It's not the easiest thing to do. Okay, but, you know, that's you and your graphing calculator, but that's not required. So I've given you the model right there. And the reason I said it's not that easy to do, it's easy enough to do, but look at those numbers. Now this, though, we can put that in a graphing calculator or a scientific calculator, and it'll calculate it for us. It says in part B, after 6 drinks, a person weighing 160 pounds will have a BAC of about 0.16. How many times more likely is a person with this weight to crash if they drive after having a 6-pack of beer? Round to the nearest 100th. Okay. So you're going to put this in your calculator, a scientific calculator. They're just long numbers to put in. By the way, when you do this really large number, you don't use the commas. You just put in 22, 22072021300. Okay, and you're going to raise that to the power of x because it is exponential. And you have to know which is x and which is y. What's your input, what's your output? Well, if you remember, the input x was the BAC. Okay, so our BAC is 0.16. So I want to put all those numbers. I have to make sure I put the parentheses in. And then I'll use the exponent button to put in 0.16. When I put it in my calculator, I got about 26.346. But it says to round to the nearest 100th, so I'm going to say it's about 26.35. Okay.